Okay, so now we're going to do a worked example that has a look at tangents and normals in a little bit more detail.
Alright, so this question says for the function f of x is equal to x cubed minus x squared plus 1, find the coordinates of the points where the gradient is perpendicular to the line y equals negative x plus 3, hence find the equations of the tangents and normals at these points. Well, there's a fair bit of information there, so let's go through and highlight all of the key points. So for the function f of x is equal to x cubed minus x squared plus 1, that there is a key point. Writing in the key point now, f of x is equal to x cubed minus x squared plus 1. Next key point, find the coordinates of the points where the gradient is perpendicular to the line y equals negative x plus 3. So we want to find the coordinates of the points. Find coordinates x1, y1. That's what we're looking for, where the gradient is perpendicular to the line y equals negative x plus 3. So m is perpendicular to y equals negative x plus 3, and because it says perpendicular, that means we need to use the formula mn is equal to negative 1 over mt, where mn is the gradient of the normal and mt is equal to the gradient of the tangent. So hence, find the equations of the tangents and normals at these points. Find equations of tangents and normals at this point. Alright, so first of all it's telling us to find the coordinates where the gradient is perpendicular to the line y equals negative x plus 3. Okay, so first of all we need to find out what gradient is perpendicular to the line y equals negative x plus 3. Okay, so perpendicular means find the gradient of the normal. Therefore we need to use the gradient of the normal formula in order to be able to do this. And of course the gradient of the normal is equal to mn is equal to negative 1 on mt. Substitute that in now, so we're looking for the gradient of the normal, so mn is equal to negative 1 over the gradient of the tangent. Well, the gradient of the tangent happens to be the number out the front of the x, that is here. So the gradient of the tangent is equal to negative 1. Negative 1 divided by 1, which is 1. Okay, so now I know what gradient I'm looking for. I can find the gradient of the tangent for f of x equals x cubed minus x squared plus 1, where the gradient is equal to 1. Remember, f dash of x means gradient. Okay, so to find the gradient function, or the how steep function, what we need to do is we need to find the derivative of f of x, so that is f dash of x is equal to 3 times 1 out the front gets you 3, x, drop the power by 1 from 3 gets 2, minus 2 times 1 is 2, x, drop the power of 2 by 1 gets you 1, and you don't need to write 1, plus 1, when you derive 1 you get 0, so therefore the gradient function is equal to 3x squared minus 2x. Okay, so let's just come up here and continue on with it. So I know the gradient is equal to 1, so therefore I want to substitute f dash of x equals 1. So I'm going to write the formula out again, f dash of x is equal to 3x squared minus 2x, and because I know f dash of x is equal to 1, I can substitute f dash of x at 1, so you get 1 is equal to 3x squared minus 2x. So because we've got two types of x, we're going to need to factorize, so we're going to remove the 1 over here, so we go 0 is equal to 3x squared minus 2x minus 1, because we've just subtracted 1 from this side over here. And let's factorize now, so you get 0 is equal to, right, so 3 times negative 1 is negative 3, so let's think of the factors of negative 3 that add to negative 2. Alright, well if you go negative 3 times positive 1, that will get you negative 3, and negative 3 plus 1 gets you negative 2, so we're going to break this up. 3x squared minus 3x plus x minus 1. So this here, this negative 2x here, we've rewritten out as negative 3x plus x. If you do negative 3x plus x, it's still equal to negative 2x, but we've now broken up into 4 terms, which is easy to factorise. So you get that is equal to 3x squared minus 3x, take out the 3x as a common factor, and you are left with x minus 1 in the brackets. Plus, take out just 1 as a common factor for the last two, so you get 1, and x minus 1 in the brackets. So this section here, we are factorising the first terms, and for the second section, we are factorising the second two terms. Alright, now with a common binomial factor, you end up getting out the front, you combine this term here and this term here, so you get 3x plus 1 in one bracket, and x minus 1 in the other bracket is also equal to 0. Alright, let's solve for x now, so therefore 3x plus 1 is equal to 0, or x minus 1 is equal to 0. Solve for x means you subtract 1, so you get 3x is equal to negative 1, therefore x is equal to negative 1 on 3, or x is equal to, add 1, 1. Okay, so we found the x coordinates where the gradient of the tangent is equal to 1. I still need to find out the y coordinates. That is, the x coordinate where the gradient is equal to 1 is at -1 over 3, comma, question mark, because I don't know how high up it is, I just know the x coordinate, and also at 1, comma, question mark. I need to still find out the y coordinates by substituting into the how high rule. So to do that, I go f of x, being the how high rule, is equal to x cubed minus x squared plus 1. Okay, so let's start off with the easy one and find the y coordinate for x equals 1. Alright, so to do that we need to substitute x equals 1 into the how high rule, that is f of x is equal to x cubed minus x squared plus 1, which is written here. And to do that we go f of 1 is equal to 1 cubed minus 1 squared plus 1, which gets you 1 cubed is 1 minus 1 squared is 0 plus 1 gets you 1. So therefore the first coordinate is at the point 1, 1. Okay, so to find the y coordinate for the other one here, it's a little bit harder. We're going to substitute in -1/3 for x into the how high rule. Okay, so I've just written out the how high rule, which is f of x is equal to x cubed minus x squared plus 1. Substitute in -1/3 now, and when you go through and put that into your calculator, you end up getting the answer 23 over 27. So the coordinates of this point are -1/3 and 23, 27. Therefore, the coordinates of f of x is equal to x cubed minus x squared plus 1, where the gradient is perpendicular to the line y equals -x plus 3, are 1, 1, and -1/3, 23 over 27. Okay, so now that we've managed to actually go through and find these points, what we need to do is we need to use them when finding the equations of the tangents and normals at both of these points. So let's make some room for this. Okay, so what I've done here is I've just written out the coordinates of the points that we've just found before, the gradient of the tangent that we found, and the gradient of the normal that was given to us. Alright, because the question's asking us to find the equation of the tangent that is perpendicular to the line y equals -x plus 3 on the function f of x is equal to x cubed minus x squared plus 1, what we need to do is we need to use the formula y minus y1 equals m bracket x minus x1. Now we know the coordinates of y1 and x1. There's going to be two answers for this because we found before that there was 2 points where the tangent of the curve was equal to 1. Okay, so we're going to substitute both points in. So let's substitute in the first point first of all. So that is 1, 1. So you get y minus y1 being 1 equals m, which is 1, bracket x minus x1, which is also 1. You get y minus 1 is equal to x minus 1. Rearrange, so you end up getting y is equal to x. For the second point, you get y minus y1 is equal to m bracket x minus x1. Okay, so finding the equation of the tangent once again, we're substituting in the other point now. You get y minus y1 being 23 over 27 is equal to m being 1, x minus x1 being -1/3. So you get y minus 23 over 27 is equal to x plus 1/3. Rearrange now, you get y is equal to x plus 1/3 plus 23 over 27. Common denominator now, so you get x plus 9 over 27 plus 23 over 27 gets you y is equal to x plus 32 over 27. Therefore, the equations of the tangents at these points are y equals x and y equals x plus 32 over 27. Okay, so let's find the equations of the normals now. So once again, we're going to use the same points as before, being 1, 1 and -1/3 and 23 over 27. And the gradient of the normal is equal to -1. So to find the equations of the normals, we once again need to use the y minus y1 equals m bracket x minus x1 formulas for both points. There's the point 1, 1 and -1/3 23 over 27. Okay, so let's first of all substitute in the point 1, 1. So you get y minus 1 is equal to m being -1, bracket x minus x1 being 1, which gets us y minus 1 is equal to -x plus 1, which gets us y equals -x plus 2. Next equation now, you get y minus y1 being 23 over 27 is equal to m being -1, x minus x1 being -1/3. Go through and simplify now, so you get y minus 23 over 27 is equal to -1 bracket x plus 1/3, which gets us y minus 23 over 27 is equal to -x minus 1/3. Add the 23 over 27 to the other side now, so you get y is equal to -x minus 1/3 plus 23 over 27. use a common denominator, so you get y is equal to negative x minus 9 over 27 plus 23 over 27, which gets us y is equal to negative x plus 14 over 27. Therefore, the equations of the normals at these points are y is equal to negative x plus 2 and y is equal to negative x plus 14 over 27. And that's it.
Okay, so now that we know all about the gradient function f dash of x and the original function f of x, let's compare the two when we plot them both on a graph.
Okay, so for the last worked example in the topic finding derivatives by rule, the question asks us, graph the function f of x equals x cubed minus 2x and f dash of x on the same set of axes, and then b, how can f dash of x be used to predict the location and nature of the stationary points? Alright, to make this nice and quick and easy, I'm going to use the CAS calculator to help us out with this. Right, I'm going to find what f dash of x is equal to, so we need to define the derivative, so I go menu, calculus, derivative, d over dx, type in the function, so you get x cubed minus 2x, press enter, equals 3x squared minus 2. Okay, let's think about this in our head. What we get is we go 3 times the number out the front is 1, so 3 times 1 is 3x, drop the power by 1 is 2, so 3x squared. And then you derive this part, so you get negative 2x derived becomes negative 2. So now what we're going to do is we're going to put both functions into a graphs page. So you're going to go home, graph. Okay, so press tab to put in the first function. So you go x cubed minus 2x, press enter. There's the first function. And we're going to press tab to put in the derivative function, which was 3x squared minus 2. So the blue function is the original function and the red function is the gradient function. Now I've actually answered part A where it says graph the function f of x equals x cubed minus 2x and f dash of x on the same set of axes. We've just done that there. The next question says how can f dash of x be used to predict the location and nature of the stationary points? Right, remember f dash of x is the red one, so we're going to look at the red one here. Now as you go down, remember this is the gradient. So when we're looking at an axis, what we have is the y-axis is equal to the steepness. Right? So therefore where it crosses here, the steepness is equal to 0. If you have a look at this point right here where the sort of tool is, the steepness graph is equal to 0 at the same point where the gradient is equal to 0 over the blue line. Come all the way down and across to the right once again, and the how steep graph is equal to 0, and once again the blue graph has a gradient of 0 at this point. To figure out the nature of it, well, if we have a look here, the steepness graph is positive, hits 0 at that point, and then becomes negative, so therefore it's a local maximum. Looking at this point here where the gradient is equal to 0, well, before that x value the steepness graph is negative because it's below the x-axis, so therefore the gradient of the blue graph is going down. As soon as it hits the same x value as you can see here, the gradient of this blue graph starts going up and the gradient function becomes positive.
Okay guys, thank you very much for tuning into my lesson on finding the derivative by rule. Now I know it was a long one, so thank you very much for staying tuned the whole time. I'm glad I spent the whole time on the couch and I hope you did too. Alright, now remember to stay tuned for the very next lesson, which is all about finding rates of change. Now I've actually gone through some very similar skills in the previous topic, so it shouldn't be too difficult for you. Alright, now like always, make sure you say hi to your maths teacher for me. Morsey out. Cool.